In this video, we will learn about the law of sines and the law of cosines. Let's say we're trying to find this missing side of the triangle BC. So I'll put an X right there. We're going to try to solve for X. Okay, so we got to pick an angle first. We know that. I could pick this one. That's 28 degrees. And from that, X would be the opposite. And then 18 would be the adjacent. And AC would be the hypotenuse. But we don't know anything about the hypotenuse. Maybe we could use tangent, maybe not. But wait a minute. Angle B is not a right angle. Neither is angle A or angle C. This is not a right triangle. We cannot use the normal trig functions like we did before. There must be some other way that we can figure out what side BC is going to be. As I said in a previous video, trig functions as we learned them before only work for right triangles, but many triangles are not right triangles. They are acute or they are obtuse. In order to solve for missing parts or missing angles of these triangles, we are going to use either the law of sines or the law of cosines, or both. The law of sines works particularly well when you know two or more angle measures and at least one side length. It also works in cases where you know two sides and the non-included angle, but complications can arise, including the ambiguous case. The law of cosines is very useful when you know two sides in the included angle, or if you know all three sides of the triangle. And many times you end up using a combination of law of sines and law of cosines. Before we get into using law of sines or law of cosines, it's really important that we start naming our triangle in a particular way. The first step is to name each of the vertices A, B, and C. Now, it doesn't matter which vertex is A, which one is B, and what one is C, just that each of them is its own vertex. And in something that seems a little bit counterintuitive, each of the sides are also going to be named A, B, and C. But make sure you use lowercase a, lowercase b, and lowercase c when naming the sides. And most importantly, make sure that side A is opposite of angle A. And side B is opposite of angle B. And side C is opposite of angle C. That's really the important part. The law of sines is a proportion that allows you to find the missing side or angle values in many acute or obtuse triangles. The law of sines states that the sine of angle A in a given triangle divided by the length A will be proportional to both the sine of angle B divided by side B and the sine of angle C divided by side C. Let's go back to that problem that we started with. We were trying to find BC, but we noticed that the triangle was not a right triangle. Well, the law of sines doesn't need to be a right triangle. The first step to using the law of sines is to make sure that any missing side or any missing angle is labeled correctly. In this triangle, we have the angles labeled A, B, and C, and that is correct. And we even know that side C is 18 feet. But let's label the two missing sides. We can label side BC simply as A because it is opposite angle A. And we can label the long side at the top B because it is opposite of angle B. We know a lot of information about this triangle, so let's fill out our law of sines as best we can with all the information given to us. So instead of sine A, we know that the measure of angle A is 28 degrees. And side A is unknown, so we'll just put an A there. The sine of angle B, we don't know what that is, so we'll just leave it like that. And we don't know what side B is either, so we're probably not going to use that part of this proportion. But we know that angle C is 25 degrees, and side C is 18 feet. I'll just leave it as 18 for now. Now, it is really important that at least one of these proportions has an angle in the top and a side length in the denominator. And as long as you have the numerator filled out completely and the denominator filled up completely, you can continue using the law of sines. If you ever run into the situation where you don't have both the numerator and denominator filled out out of at least one of these fractions, you have to stop using the law of sines and move on and try to use the law of cosines. Since the sine of angle B over side B is not filled out at all, and none of that information is what we're actually looking for, we actually don't need that as part of this. So if we rewrite our proportion omitting the sine of B over B, we will have the sine of 28 degrees over A equals the sine of 25 degrees over 18. And this proportion only has one variable that is unknown in it, and that is A. We know what the sine of 28 is, or we can find it out. We know what the sine of 25 is, and we know that 18 is an integer, which is great. So we can solve this proportion using the cross product. So I'll start off by swapping my location of A in the sine of 25 because I want my variable to be in the numerator. And while I'm at it, I'm also going to multiply 18 by both sides. That leaves me with 18 times the sine of 28 degrees over the sine of 25 degrees, and that equals side A. Now, if you have a sophisticated enough calculator, you can do this in all one step. If not, you can do it piece by piece. Just make sure you use like 5 or 6 decimal places to make sure that everything stays accurate all the way through. But I did it all in one step on my calculator, and I got A is approximately 19.99556. So to the nearest whole number, side A is approximately 20 feet. Sometimes in mathematics, you're asked to solve a triangle. What that means is that you find the measure of every side and every angle of the triangle. When I solve a triangle, I put it in a table like this. The angle measures in one row, and we have angle measure A and angle B's measure and angle C's measure. And then we have the 3 side measures. Since a triangle always has 3 angles and 3 sides, keeping in this table will actually make it easier for you to visualize what you still need to solve for. Also, I put the angles on top and the sides on the bottom, and the reason is because then it lines up with the law of sines. So the sine of 37.6 divided by 7.2 will equal the sine of 76 degrees divided by 11.5, and that will also equal the sine of 66.4 degrees divided by 10.8. So it lets me think about it in terms of law of sines, and that also makes it easier for me to solve these problems. So let's try to solve this triangle. I have a triangle and the vertices are labeled A, B, and C, which is perfect. For sides, we have one measurement, AB, which is 26. That's also side C. And what we're missing is a B here and an A here. And if we can also figure out what angle C is, I think we'll be in pretty good shape there. So let's fill out our table with what we know already, and then we'll know what to look for, and we can make our proportion. So angle A is 22 degrees. Angle B is 123 degrees. And side C is 26 units. We don't know what the unit is, so we'll just leave it as 26. All right. Now looking at this, we don't have any column that the numerator and the denominator is filled out, so we can't use law of sines quite yet. But I think I could figure out what angle C is without doing any trigonometry. I know that all the angles inside of a triangle add up to 180 degrees. So angle A being 22 degrees plus angle B at 123 degrees plus the measure of angle C should add up to 180 degrees. So if we subtract 123 from 180 and 22 from that, we will find out that angle C has to be 35 degrees. Okay, let's fill out our law of sines now. We know enough information. I think we can make it happen. So the sine of 22 divided by side A equals the sine of 123 divided by side B, and that equals the sine of 35 divided by the side 26. All right, and you can see how the table I constructed is very similar to the law of sines. We just added in the word sine to the top ones and set them equal to each other. Okay, we can't solve for A and B at the same time. So let's just solve for A first. So we're going to ignore the sine of 123 over B part. And since everything is equal to itself, we can put it in any order we want. So I'm going to solve the proportion, the sine of 22 over A equals the sine of 35 over 26. This is a proportion that we can solve. It has only one variable, and that's A in the denominator. I'm going to actually solve it in a very similar way to the way I solved the last example. I'm going to swap the location of sine of 35 in A, and I'm going to multiply at the same time 26 by both sides. So 26 times the sine of 22 over the sine of 35 will equal A. Excellent. And I can put the whole thing in my calculator at the same time and find out that A is approximately 16.98. And now that I know that, I can put it into my table. Which is great. Now let's find B. And in order to find B, I'm going to use sine C divided by 26, sine of 35 divided by 26 equals sine of 123 over B. I'm not going to use the solution I just got for A because I know that's a rounded value. And if I make my proportion out of what I know of B and what I know of C, it will not be rounded values. I'll get a more accurate answer. So let me write that. So here we have the sine of 123 degrees divided by B equals the sine of 35 divided by 26. And in order to solve this, I'm going to swap the locations of B and the sine of 35 and multiply 26 from both sides, and I will get 26 times the sine of 123 degrees divided by the sine of 35 degrees equals B. And placing that into the calculator, I will get B is approximately 38.02. And I could put that in my table. And I have now solved the triangle. I know what every angle measures, and I know what every side length is. Consider this triangle solved. And as usual, here is a much neater version of what I just had. Here we have an example where I'm just given angle measures. I actually don't have a picture of the triangle, but I know that angle A of this triangle is 27 degrees. I know that side A of the triangle is 8, and I know that side C of the triangle is 12. So I know 3 pieces of information, so I can probably move forward and solve this triangle. I think I can find angle C pretty quickly if I use the law of sines. And then once we know what angle C is, we can find out what angle B is and then use the law of sines again to find the other missing side. So let's get to that. first let me set up my law sines part. So the sine of 27 degrees divided by 8 equals the sine of C over 12. Great. We only have one variable, and it's an angle, which is great. So if we move 12 over to the other side by multiplying it by both sides, we'll end up with 12 times the sine of 27 divided by 8 equals the sine of C. And then if I want to find out what that angle is, I just need to take the arc sine of the entire other side. So sine, arc sine of the entire quantity, 12 times the sine of 27 degrees divided by 8 equals angle C. All right, let me do this really quickly on my calculator. After typing it into my calculator, I found that angle C is approximately 42.92 degrees. And I know that's a rounded value, but I could still get a pretty close rounded value for angle B. I just need to say that 27 degrees plus the measure of angle B plus 42.92 degrees will equal 180 degrees. And solving for angle B, you get 110.08 degrees. Excellent. Now we can just use the law sines one more time. I'm going to switch colors here, and I'm going to use angle A inside A equals sine of angle B divided by side B to solve for that one missing thing we have, which is side B. So here we go. Sine of 27 divided by 8 equals sine of 110.08 divided by B. And to get B completely by itself, I'm going to swap its location with the sine of 27. It's a pretty standard property of proportions. And I'm going to multiply 8 by the numerator of sine of 110.08. That will look like this. All right. And then solving that on my calculator, I get B is approximately 16.55. That's great. I solved this triangle. It's a side-side angle triangle, and I solved it. Although it did say that there was something called an ambiguous case that can happen in this case. I don't know what that is. This looks like a pretty standard triangle, and it seems that, like our biggest angle is angle B, and that matches up, that's opposite our longest side, 16.55. And then A is our smallest angle, and side A is our smallest side. That makes sense. And angle C is 42.92, which is in the middle, but definitely closer to 27. And then the side is 12. It seems like everything works out here, but let's see if there's another way I can draw the triangle other than with these measurements. All right, I have two triangles here. One of these looks like the triangle I just solved. The one on the right here, this angle right here looks like it could be 110 degrees. And this angle right here looks like it could be 43 degrees. And this side right here looks like it certainly could be 16.5 if this is 12 and this is 8. All of that makes sense to me. So what's the deal with this other triangle over here? Well, we were given that angle A is 27 degrees and side A is 8 and side C is 12. And in this diagram, angle A is 27 degrees side A is 8, opposite of angle A, and side C is 12. This is a case where there's two triangles you could have made with those same dimensions. And we're going to have to solve for both of them. That's why it's called ambiguous. If you're given just the information you were given, you can actually make two different triangles out of that. And so it's our job to solve both of those triangles. So what we did before isn't wrong. It's just only half of the answer. It's one of the two ambiguous cases. Now we're going to figure out what the other triangle is. So the first thing we initially did was find out what angle C is, and we're going to do that again quickly. Okay, so the sine of 27 divided by E equals the sine of C divided by 12, and I solved everything for angle C, and I found angle C again to be 42.92. If that was too fast, just go back a little bit in the video, and we'll go through how to do that again. But that was my initial answer for C. And I know that there has to be a different measurement if there is a second triangle. So what I'm going to do is subtract angle C from 180 degrees and see if that could be a possible value for angle C rather than 42.92 degrees. So 180 minus 42.92 is 137.08 degrees. And if that leaves us enough room to also have an angle B, then this would be the measure of our second triangle. So 180 minus 137.08 minus 27, the two angles that we know, is there enough room to make an angle B in this triangle? And yes, if we subtract 137.08 and 27 from 180, we have 15.92, which doesn't seem like a very big angle, but it's big enough to be an angle B. And we noticed from that diagram that angle B was going to be very acute. So 15.92 certainly could be the measure of that acute angle. And now for the second triangle, all we have to do is use the law of sines to figure out what side B is going to be. So let's set that up. So using our angle inside from A, sine 27 over 8 equals sine of 15.92 divided by B. We can solve for B and get B equals 8 times the sine of 15.92 degrees divided by the sine of 27. And using my calculator, that reduces to approximately 4.8. And that will be our side B in our second triangle. And it's still a triangle. 4.8 plus 8 is greater than 12, so it is a triangle. It is just the second possibility of a triangle when angle A is 27 degrees, side A is 8, and side C is 12. Now, every time you have two sides in the non-included angle, you're not going to have two triangles. So going back over here, when we subtracted 180 minus 42.92 to get 137.08, sometimes this number is too large to fit angle A and another angle in. Like if we were subtracting from, instead of 42.92, let's say we subtracted from 20, there wouldn't be enough room left in order to have a third angle in there. So sometimes you have to solve for two triangles. Sometimes it's only one triangle. And then sometimes there is no possible triangle given the dimensions. It's just something you have to be careful for. Excellent. Let's attempt to solve this triangle. Okay, we have side A, which was not given to us. I'm just going to write an A in the diagram. We have sides B and C, though. We have angle A. We don't know what angle B is, and we don't know what angle C is. But let's fill out our table. So angle A is 127 degrees. Angle B and C we don't know. Side A we don't know. Side B is 20 meters. I'll just write a 20. And side C is 18 meters. Great, so we have three pieces of information. That should be enough to solve this. But there's a problem here. We don't have any angles and the side beneath them filled in completely. And before we had that, but we had two angles and we could figure out what the third angle was, and that completed a numerator and denominator for law of sines. But in this case, we don't have any of that information. We just can't use the law of sines yet to solve this. So we're going to have to move over to the law of cosines. The law of cosines is not simply one proportion like the law of sines is. It's actually 3 different equations, which then can be solved into 6 different equations. Generally, the standard form is the only one given, and if you're trying to find an angle measure, you have to solve it for that angle. But I gave you all 6 of possibilities in one table. If we're looking for to solve for angle A, or let's start with the sides. If we look to solve for side A, we can use this first equation, which has sides B and C squared minus 2 times side B times side C times the cosine of angle A. So here you can see we're only using on this side sides B, C, and then angle A. And then when we're solving for B, we're using sides A and C, and we're using angle B. And to solve for C, you're using sides A and B, and then angle C. That will fit in with what we have going on in our problem as well. So let's take a look at that. So here we know what angle A is, and we know what sides B and C are. So the first thing we can do is try to solve for side A. And in order to do that, I'm going to use the law of cosines for side A. We're going to use the side A formula for the law of cosines. A squared equals B squared plus C squared minus 2BC cosine A. And let me substitute the values that I have, and to make sure that I can actually solve that equation. All right, holy smokes, this is a well filled out equation here. 20 squared plus 18 squared minus 2 times 20 times 18 times the cosine of 127 degrees. It all fits. That's a big, long equation, though. Luckily, we have advanced calculators at this point, and we can do it either using iPad calculators or using a physical calculator. And so I'm going to do that. Very nice. So A squared will be 1,157.306817. I used all those decimal places because the next thing I have to do is find out what just A by itself is going to be. And so I want a couple extra decimal places to make sure that when I take the square root of that large number, it still gives me a fairly accurate answer if I go to, let's say, 2 decimal places. So I'm going to take the square root of that number I just got, 1,157.306817, and get 34.02. And I'll put that in for my side. Okay, now that we have that side length, and I know at least to 2 decimal places it's accurate, so it should be fairly accurate for the next couple of angles. You know what, I'll probably just keep those down to the nearest degree, and as long as I do that, I should be plenty accurate enough. But 34.02 is now side A, and I already knew angle A was 127 degrees. Now I know enough information to use the law of sines to find either B or C. It doesn't matter which one we find first. I'll just find B first because I really like the alphabet. Okay, so our objective is to find B using the law of sines. And so I made my proportion sine of 127 degrees divided by 34.02 equals sine of B over 20. I only have one variable. It is angle B, and I can move the 20 over to the other side of the equation by multiplying it by the sine of 127, and then take the arc sine of that entire side to find what B is, and that is. So the arc sine of the quantity 20 times the sine of 127 degrees over 34.02 is approximately 28.003. So we'll just call that 28. All right, now finding angle C is actually going to be pretty easy because we know that angle A plus angle B plus angle C add up to 180 degrees. And so I can write that as an equation, and I don't actually need to use the law of sine again. I could use the law of sine again, but I can just subtract to find angle C. So let me set that up. So here we have 27 degrees plus 28 degrees plus the measure of angle C will add up to 180 degrees. Well, if I subtract 127 degrees and 28 degrees from 180, I will find the measure of angle C to be equal to 25 degrees. For all of you that like when I put a neater example of all the work I did. This is our final example in this video. We're going to solve a triangle knowing only the side lengths, knowing none of the angles. So I have my triangle, it's all drawn out, and I have all my side lengths in my table, but I can't make a proportion out of any of these. So obviously I need to use the law of cosines in order to solve for at least one of these angles. I technically could use it for all three, but I think I'll use it for two of these. We'll see how it goes. Since I've already professed my appreciation for the alphabet, I'm going to solve for angle A first. And in order to do that, I'm going to use the law of cosines that's solved out for angle A, and that is the cosine of angle A will equal b squared plus c squared minus a squared all over 2 times b times c. Now, filling in the information I have in my table, I can get. Now, if I solve this, it actually will be easier if I keep it in fraction form. So 17 squared plus 11 squared minus 10 squared is 310. And 2 times 17 times 11 is 374. And I can use arc cosine to find what 310 over 374 and get a really accurate answer. So A is approximately arc cosine of 310 over 374, and that will give us a very accurate answer of 34.02. Now, you may notice we could actually start using the law of sines here because we have one angle and side for A on top of each other. But let's give a little more practice with the law of cosines. So I will find angle B using the law of cosines. So let me first pull out the equation for angle B. So the cosine of B is a squared plus c squared minus b squared over 2ac, which filled out for this particular problem is 10 squared plus 11 squared minus 17 squared over 2 times 10 times 11. Now I'm going to keep this in fraction form, and I want you to notice that the numerator of 10 squared plus 11 squared minus 17 squared is negative. That's actually okay. All that means is that angle B is going to be obtuse. It's going to be greater than 90 degrees because in the second quadrant, cosine is negative. It makes total sense now. So negative 68 over 220. And so I can further this by saying B equals arc cosine of the fraction negative 68 over 220, and that will be approximately, on my calculator, 108.004. So like I said, it's obtuse, and that's great. We're using the law of cosine, so our triangle is either going to be acute or obtuse. It's not going to be right either way, so having an obtuse angle there is just fine. I'm just going to write that as 108, though. All right, what do you think angle C is? Now, we could use law of cosines one more time for angle C, and it would give us a very accurate answer, but I prefer just to subtract. So 180 minus 34 minus 108 is approximately 38 degrees. And going back to our first one, let's just pull off the 0.02 just for consistency. So angle A will be 34 degrees, angle B will be 108 degrees, and angle C is 38 degrees. Here is the typed out version of that last problem. I think we're ready. I think we're ready to try some of these on our own. All right, let's get to it.